Today I am going to start multiple integrals. Example 1. Change the order of integration in integral from 0 to a, y to a, x divided by square root of x square plus y square into dx dy, and then evaluate it. The region is bounded by the lines x is y, x is a, y equal to 0 and y equal to a. Before drawing the region, we have to verify whether the double integral is given in the correct format. It is dx, order dx given, therefore we have to verify the limit must be a function of another variable y. So after marking x is y, x is a, y equal to 0 and y equal to a, we are getting the region like this. So after changing the order of integration, the above integral becomes double integral x divided by square root of x square plus y square into dy dx. We are going to integrate the function with respect to y first. Therefore, we are getting log of y plus square root of y square plus x square. The limit is from 0 to x. Apply the limit x for y. Therefore, we are getting log of x plus x into root 2 minus log x. Take x outside. So, log of x into 1 plus root 2 minus log x. But this is of the form log a minus log b. So, log a by b, where x getting cancelled. Remaining log of 1 plus root 2. This is a constant term. This term can be taken out. Therefore, in the next step, log 1 plus root 2, integral from 0 to a, x into dx. Integral x dx, we are getting x square by 2. Apply the limit 0 to a. Therefore, we are getting a square by 2 into log of 1 plus root 2. This is the answer of the given double integral. Moving to the second question. Change the order of integration in integral from 0 to 1, x to 1, x into dx dy by x square plus y square, and then evaluate it. Step 1. Correct the given integration. Here the order is given to us dx, but the variable limit is x to 1. So write the correct integration first. I am writing here integral from 0 to 1, x to 1, x dy dx divided by x square plus y square. After writing the equation, find out all the points. The region is bounded by the lines x is 0, x is 1, y equal to x and y equal to 1. Based on the above points, we are drawing the first line y equal to x. The vertical line x is 0 and the horizontal line is y is 1, and the vertical line we are putting here x is 1. After changing the order of integration, we are getting I equal to integral from 0 to 1, 0 to y, x dx dy by x square plus y square. Integrate this function with respect to x first. So 1 by 2 log of x square plus y square, and the limit is from 0 to y. Apply the limit now. So log 2y square minus log y square. This is of the form log a minus log b. So log a by b, y square getting cancelled. So 1 by 2 log 2 is a constant term. This term can be taken out. The remaining integral from 0 to 1 dy. If you integrate dy, we are getting y and the limit is 0 to 1. So final answer is 1 by 2 log 2. Moving to the third question. Change the order of integration in integral from 0 to b, 0 to a by b into b minus y. xy dx dy and then evaluate it. Where order of integration is given to us dx dy. So order is dx means the variable limit must be a function of another variable where y given. So this is the correct integral. To find the solution of this one, first we are going to identify the region of integration is bounded by the lines x is 0, x equal to a by b into b minus y. This cannot be marked directly in the graph. So we are going to write bx is equal to ab minus ay. When we divide throughout by ab, we are getting x by a plus y by b equal to 1. Based on y equal to 0 and y equal to b. Based on the above equation, we are going to draw x, y is equal to b, x is 0, y is equal to 0 and the line equation is x by a plus y by b equal to 1. After changing the order of integration, I equal to double integral xy dy dx from 0 to b by a into a minus x from 0 to a. When we are integrating this with respect to y, we are getting y square by 2 and the limit is 0 to b by a into a minus x. So after applying the limit, we are getting the constant b square by 2a square from 0 to a x into a minus x the whole square into dx. Expand a minus x the whole square, multiply by x, then integrate with respect to x. That integration is given here a square x square by 2 minus 2a x to the power 3 by 3 plus x to the power 4 by 4. Apply the limit 0 to a. After applying the limit, we are getting the solution a square b square by 24. Moving to the fourth question, change the order of integration in integral from 0 to 1, y to 2 minus y, xy dx dy and then evaluate it. The region of integration is bounded by x is equal to y, x plus y is equal to 2, y equal to 0 and y equal to 1. So we are going to mark the line x is equal to y. It passes through origin and the line equation x plus y equal to 2. Then y is equal to 1 and y equal to 0. So after changing the order, our integral becomes I equal to double integral xy dy dx. To find y limit, we are going to consider the vertical strip in the region. If we consider vertical strip in the beginning, the limit is 0 to x. If we consider the vertical strip in the end, we are getting the y limit 0 to 2 minus x. Therefore, we are going to divide the region into two parts. First region is I1, second region is I2. For the region I1, y limit is 0 to x and x limit is 0 to 1. For region I2, y limit is 0 to 2 minus x and x limit is 1 to 2. Now we are going to integrate I1, I2 with respect to y, then with respect to x. So we are getting integral from 0 to 1, x into y square by 2, limit is 0 to x into dx, plus 1 to 2, x into y square by 2, integral from 0 to 2 minus x into dx. So after applying the limit, the next step we are getting integral from 0 to 1, x to the power 3 by 2 into dx, plus 1 to 2, x into 2 minus x the whole square into dx. Therefore, we are getting x to the power 4 by 8 from 0 to 1 plus 1 by 2, 2x square minus 4 by 3 x cube plus x to the power 4 by 4 from 1 to 2. So after applying the limit, first integral value is 1 by 8, second integral value is 5 by 24. If we add the two values, we are getting 1 by 3. This is the final answer of this question. Next, we are going to find area of a double integral using Cartesian coordinate. The formula is given by a equal to double integral dy dx. we see one example. Find the area of the circle x square plus y square equal to a square. So we are going to draw the circle like this. To find the area of the full circle, it is enough to find the area only in the first quadrant, then multiply by 4. Therefore, the equation is given by 4 into double integral dy dx. It means first quadrant. So we want y limit, then x limit. To find y limit, we are going to take the vertical strip like this. If you take the vertical strip, the lower end touching the equation x is 0 and the other end touching the circle. Therefore, y limit is from 0 to square root of a square minus x square and x limit is from 0 to a. Therefore, we are getting 4 into integral from 0 to a square root of a square minus x square into dx. So, find the integral of this. Standard formula is available for integrating this. So, x by 2 square root of a square minus x square plus a square by 2 into sin inverse x by a. Apply the limit 0 to a. When you apply the upper limit a for x, first term a square minus a square is 0. Second term a square by 2 into sin inverse 1. Sin inverse of 1 is pi by 2. Apply the lower limit, we are going to get 0. Therefore, we are going to get the answer pi a square. Next, we are going to find area as a double integral in polar coordinates. But the formula is given by a equal to double integral r dr d theta. Find the area of the cardioid. R equal to a into 1 plus cos theta. To trace the curve, we are going to take theta value and r value. When theta is 0, r equal to 2a. When theta equal to pi by 2, r is a. When theta equal to pi, r is 0. First, we are going to mark this is r is equal to a and here r is a. Here also we are substituting. Therefore, we are tracing the curve like this. So, cardioid curve, we are getting the heart-shaped curve. When we substitute r is 0, cos theta equal to minus 1 to 1. So, area is given by double integral r dr d theta. To find r limit, we are going to consider the radial strip in the region. Our radial strip is given by OP. OP is the radial strip. So, therefore, limit of r is from 0 to a into 1 plus cos theta. And theta limit, we can move the radial strip from the initial line to this one. So, initial line theta is 0 and up to this theta equal to pi, but which is symmetric about the initial line. So, we are getting twice of 0 to pi. So, integrate with respect to r. So, we are getting r square by 2. Apply the limit. After applying the limit, we are getting a square into integral 0 to pi 1 plus cos theta the whole square into d theta. Expand this 1 plus cos square theta plus 2 cos theta. This cannot be integrated directly. So, apply the formula for cos square theta 1 plus cos 2 theta by 2. Now, we are going to integrate with respect to theta. So, we are getting theta plus theta by 2 plus sin 2 theta by 4 plus 2 sin theta. Apply the limit from 0 to pi. First term pi, second term is pi by 2, sin 2 pi 0, sin pi 0. Apply the lower limit, all the term becoming 0. So, a square into pi plus pi by 2, we are getting 3 pi a square by 2 is the answer. Moving to the next problem, find the area outside the circle r equal to 2 cos theta and inside the circle r equal to 4 cos theta. The solution is given by the transformation equations are given by x equal to r cos theta and y equal to r sin theta. The first circle r equal to 2 cos theta. Therefore, r equal to 2x by r square minus 2x is 0. But r square is x square plus y square minus 2x is equal to 0. To convert this as a circle, adding and subtracting 1, we are getting x minus 1 the whole square plus y square equal to 1 square. This is a circle. with the center 1 comma 0 and radius is 1. Similarly, r equal to 4 cos theta, we are getting the another circle. X minus 2 the whole square plus y square equal to 2 square, center 2 comma 0, radius is 2. To find the limit of r and theta, consider the radial strip. In the radial strip, we have r limit 2 cos theta to 4 cos theta, and theta limit is 2i sub 0 to pi by 2. When we integrate with respect to r, we are getting 16 cos square minus 4 cos square. It is 12 cos square theta d theta. Therefore, we are going to integrate this with respect to theta. To find theta value, to integrate this, we are going to apply reduction formula. By reduction formula, we are going to get 12 into 1 by 2 into pi by 2. Therefore, the answer is 3 pi. Thank you.